Hi everyone, I'm excited to host Gonzalo Casas. He's a software engineer at ETH Zurich. Gonzalo has 20 plus years experience as software engineer for desktop, web, mobile and robotics, as well as extensive experience in several programming languages. I am a big fan of Compass, which is an open source development, and really curious to know the whole journey of how this tool was developed, what were the software engineering principles that were adopted, and got to get to know Gonzalo. So thanks a lot, Gonzalo, for being on the show.
Thank you for inviting me, and yeah, I'm happy to share a bit of the history and the present of Compass and the future maybe as well.
Yeah. So before we do like a deep dive in Compass, can you tell a bit about your background and out of all things you can do in life, how you got into AEC and the software development?
Yeah, that's a funny one of destiny. I'm originally from Argentina. I came to Switzerland some 15 plus years ago, I think. Um, I was always like a software developer. I started programming when I was a little kid. And I had a weird background in which at some point um, I went to the design school when I was a teenager, um, and I did some seemingly disconnected things, which at some point in life, then I started doing some hardware development, and then some years ago, 5.5 years ago, um, a friend pointed me to this opening at ETH, and he told me you have to go there. This is this is your place, and that's how I ended up in this. It's a weird match because all these things that I learned in different times of my life suddenly started to be somewhat connected
Mhm.
and making sense. Yeah.
Nice.
And yeah, yeah.
And like, what are the major differences you find in software development for architecture, engineering, and construction industry versus like other industries?
Um, well, the AC industry has a like it's a bit of a has its idiosyncrasies, its quirks. Um, but at some level, software engineering is always about interfacing with different domains. So there's a degree of generality that applies to all disciplines. Um, what I do think that it's very different in this specific sub branch of the of architecture, engineering, and construction is that in this case the users are also domain experts, which is not always the case, right? Uh,
Mhm.
with building software for developers who are also domain experts. This is well, it's happening more and more. Some I saw the same thing happening in journalism with these data journalists, but it's not something that happened 20 years ago. For instance, this is a relatively recent development of increasing um, increasing focus on development in all
Mhm.
disciplines, pervasiveness of development. And it is a very exciting it's a very exciting thing because it brings a complete new perspective on software engineering, points of view that are completely different from the standard.
Mhm. Yeah, and I'm curious to know, like, so, like, it's when we say AEC, like, there are like three different industries which we are integrating in one whole platform, and there are like, it's also fragmented, and there's like complexity. So, like, how 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 to first get started and like deal instead of like deal one chunk at a time instead of getting overwhelmed, and like from your experiences, like, are there any tips you have for us?
As an outsider of the AC industry, you mean?
Yeah.
um, well, when I started at Camacho Color Research at ETH. Um, I was in a way I was basically dropped in cold water because I had no experience with robotics, not prior experience with it, and also no experience in 3D and geometry modeling. So everything was new for me, and um, the biggest hurdle to overcome was understanding was semantics, human semantics. The small differences in vocabulary, even at everyday level, like everyday conversation level, speaking about technical things, in which certain terms mean different things than what I was used to, and it was at first it was difficult to make the switch. And this is something that actually we try to actively um, enforce or somehow bridge with Compass. Or at least acknowledge the fact that this is a reality. Different fields have different vocabularies, and we somehow need to make them talk. And it's not just about making software talk to each other. It's about making people talk different, you know, communicate at the human level as well. So defining concepts is an important part of what we try to do with Compass.
Yeah, and it also ties back like a lot of terms in software engineering are inspired from architecture. Like so you see like program or like a lot of like cement like language similarity in both field.
Yeah, yeah, like the whole building block concepts, like everything I'm relating to software architecture is borrowing a lot from real architecture. In fact, yeah.
Hmm. So Gonzalo, can you give us like a high level overview about Compass and the capabilities, possibilities?
Sure. Um, so Compass, also to give a little bit of a historical context to it, Compass was started by Tom van Melle from the Block Research Group um, many years ago as a um, as a way of helping his own team, basically just creating a bunch of scripts and functions that were useful. Um, and this thing started growing over the years. At some point, it became a framework, which for a while it was actually called BRG framework. Um, and then when there was some certain traction or critical mass, let's say internal critical
Hmm.
mass at the ETH, uh, it was decided to push it forward and rename it, revamp it, and then Compass was born, which was it was still for quite a long time. It was only an internal tool. We were using it at different chairs at ETH, but we didn't go live for like open source for a rather long
Hmm.
time. We were alpha testing it with our own with our own people. Um, until we felt a little bit like a bit more comfortable with releasing early like pre 1.0 versions, and it was also like a long while until we released the first stable API 1.0. I think it was exactly a year ago that we did that. And yeah, the Compass in general, what we try to do is we're trying to build a little ecosystem of tools that help bridge disciplines. I always say that like we're building, it's like glue code.
Hmm.
We're trying to bridge um, the because every project in the AEC industry is multidisciplinary. This is kind of a by design, this the way it has to be. So you need to interface with structural engineers, with roboticists in the digital fabrication sector, with computer scientists, data scientists, and people all coming from different backgrounds. They are using different tools, and as I mentioned before, they're also even using different language, different like vocabulary.
Hmm.
So that's what we try to do. We try to bridge bridge those disciplines and creating ways of using tools that are uh, leading tools, like state of the art tools in all these disciplines, and make them available in an environment that we want to, like we are familiar with. So CAD environments. Um, that's why in the homepage of Compass, this dry thing, do not repeat yourself or others. Don't reinvent the wheel, because this was one of the. But this is a very common problem, especially in academia, but everywhere, that people rebuild what has been built before because they didn't know someone else built it, or they didn't have access to it. So
Yeah, and I think like this diagram really gives like a real like a whole holistic picture of Compass. Like you have core, you have wrappers, you have extensions, and I'm curious to know like what was the most technically challenging things in this development? Was it like interoperability, data schema, or currently maintaining this software, or like writing those extension? Like,
um, I would say it's not exactly the biggest technical challenge, but it's the longest and most um, contentious one, let's say, at some point. Um, it's the fact that we need to support Iron Python for Rhino. Like
mm,
this creates huge additional complexity in multiple levels that we try to hide from. Well, we do hide from the users, but it's there for our for us developers. Um, it means basically that half of the framework has to be checking: are you on Iron Python? Then you can do these things. If not, you can do these other things. For example, we have an entire different implementation of WebSockets that is based on which context you are. So if you are inside CPython, like outside Rhino, we use Autobahn, which is a like very well established library. But if you're inside Rhino, we have an implementation based on .NET's WebSockets implementation, and yeah, those things need to live together and switch according to the context. But then we took that idea of switching according to context a bit further, and some years ago we implemented extension points in the framework, like a way of creating plugins, which we mostly use internally. We don't so far we don't advertise so much the fact that this is possible, but other people can actually extend. And extension points are pretty cool because they are like little interfaces that we define, um, where you define you as an implementer of a plugin, you define the conditions on under which your plugin can be used, right? So typical use cases, for instance, we have plugins for Boolean operations and meshes, right? There is no pure Python Boolean operation in Compass, but there are extension points. And then if you are in Rhino, the extension point automatically picks uh, our own internal plugin that it's based on Rhino's Boolean operations. And if you're outside, it takes something else. It can take the Blender implementation, the Seagull implementation, like different ones. And this became a good way of dealing with the complexity of having to switch, between contexts all the time, because then the 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 architecture supports that switching without having to have the code uh, having lots of conditionals everywhere.
Mhm. If I get it right, like the core may give like a geometry in particular data format, and depending on the final like software I'm using, let's say Rhino or Revit, the extension will have the operations on that data structure of the geometry, and it's contextualized based on the software.
Yeah. In concrete terms, what it means is that we have a function, for instance. Maybe maybe it makes sense that I show it in the code directly, if you want.
Yep, definitely.
Let me see. Okay.
Mhm.
Is the size, maybe the size is a bit too small. Let me increase this. So this is Compass. For example, see, this is one of the pluggables. It's an extension point. It's the way to define a Boolean union between two meshes. Right? And here we just define, but besides the documentation, there's no implementation available.
Mm,
It's just the API is defined here, and we add this decorator here that will categorize it as a pluggable. And when you open when you try to use this function from Rhino, then the plugin system will search for all the implementations available, and then it will pick the one that works. So in concrete, we have Boolean implementation in Compas Rhino, and then you have the same function. This time it's a plugin, so it's the other side of the pluggable plugin thing, which has this requirement. So in order to run this plugin, the execution context has to be able to import the Rhino namespace. If this is possible, then it will run this. And then, okay, this is the specific implementation of the Booleaning, which is based on Rhino's SDK. So yeah, and then if you use Blender, it's basically the same thing happens. Uh, we check for BPI, the Blender Python interface, and then we do the Boolean operation using Blender.
I see.
So this switching happens automatically.
So when I'm installing the package, like I install all the core as well as extensions. But when I'm interfacing, let's say with Rhino or Blender, it will automatically like find the plugin.
Yeah, and when you install Compass, you get some extensions automatically installed. But if there are other extensions that were not installed by the Compass installer, they will also be discovered. Now, that's the kind of beauty of the plugin mechanism, is that if you want to extend Compass through one of these things, you don't even have to talk to us. It's you can create your own repository with your own installable Compass package, and that will automatically be hooked into the same system, right? So if you say that you have your favorite CAD software is, I don't know, whatever,
Let's say Rhino. Yeah.
X.
Yeah.
Yeah. Um, and you have your own implementation for booleans, you can create it, install your own package in your own computer, And then when you do when you invoke the boolean function, it will automatically find yours because it's part of the whole extension mechanism.
Wait, sorry, I got a bit confused. So, for example, in Rhino command line, if I type boolean, it will override Rhino's boolean and it will take Compass boolean.
No, no, no. We're always talking about using Compas booleans. But
Okay,
when you say, give me the boolean union of Compass,
okay, okay.
then you get the right one based on context. And you can that context part can be anything. It can be some other software, and you don't have to change the source code of the core framework in order to add extensions.
Makes sense now. Interesting. Eh, Uh, my next question, like, it when you said Iron Python, I had like a multiple thoughts because one of the reason I started with Compass was I wanted to do machine learning in Rhino environment, and
Hmm.
like there was some TensorFlow framework which was not compatible with the C Python version, like Python version. So
Yeah,
I Compass was my gateway to get access to the new libraries.
yeah, yeah. We struggle with that since the beginning. I mean, we all struggle with that, right? Yeah, we're fingers crossed that this Python code thing in Rhino 8 will actually start being the primary interface soon.
Mhm. Yeah, I think it might be a good time for if you can explain like a bit on the deeper level about this mechanism and journey.
Yeah,
Yeah.
um, like the whole structure of the framework, you mean?
Hmm.
So the there is this like, how is it called? Is it Conway's law? I don't know. There is one of these like laws that says that software somehow tends to replicate the organizational structures in which it's created. And this to some degree, it's also true with Compass. At ETH, or more in general, because Compass is part of the NCCR digital fabrication program. We have a core team of Compass developers, and then every chair, every institute, and every chair in the different institutes, they have they specialize in different domains, right? And each of them can and usually does produce their own Compass extension. Right? So
Um,
this organizational structures is somewhat replicated into the architecture of Compass, for a multitude of reasons, many just pragmatic. Um, so yeah, Compass as a whole is kind of an ecosystem that mirrors a bit the way that the community using Compass is organized, right? So we have the core that has in the core part of the framework we have um, data structures, which are data structures are the way that we basically transfer concepts. This is our primary means of saying, okay, we believe that this is a something that we we all should refer to with the same name. Some of them are very generic, like a network, which is basically a graph, a directed graph, or a mesh. But then there are other structures, a bit more like robot specific structures, like a configuration and all these things. Then there are a bunch of algorithms on top of these data structures to operate on them, and core ships with a few basic extensions for the main CAD software that we use. That is Blender, Rhino, and Grasshopper, which is kind of Rhino plus some things because we extend the Rhino stuff or tweak things based on the context. Um, and yeah, very fundamental, especially if we're talking about the software architecture of Compass. What it has is this extension mechanism. Right? So a lot of these things, even including the CAD integration, it's done through plugins. So another concept, for example, that we use in Compass is that of an artist. No, an artist is a class that knows how to paint something on the screen. You give it a structure, a data structure, or an object, a geometry object, and it knows how to put it on the canvas of whatever tool that you're using. So we have artists for all of the objects for each of the CAD softwares that we support. But the selection of that is automatic. You basically have one entry point that says artist, like create me an artist for this object, and it will create you the right artist for the right type on the right context. So it will create I don't know, a robot model artist for Grasshopper, if that's the context in which you're in. And then to the left of this picture, we have a bunch of other libraries that are developed also by the core team. Mostly Tom and the BRG group use these libraries, although we are using more and more, increasingly some of them. But they are interfaces to some, let's say, state of the art geometry libraries out there. And
Gonzalo,
yeah,
sorry to disturb you. So what's the basic implementation language of code? Like, is it Python, .NET? And when you are wrapping, like, the question I have is like, does the core, does like, if there's a geometry computation, does it talk to GPU, or like, do you have other like libraries which will talk to GPU or?
the language is Python
Mhm.
primarily for everything. When we have to, we use other things, but this is all hidden. So I don't know, the bindings to Seagull, for instance, are binding to C code and C++ code. Um, but this is all interfaced in Python. It's all bindings for Python. Um, when we use .NET, we use it through the Iron Python translation mechanism anyway. We don't. We usually don't have C sharp code in the
Mhm.
library. Um, and the second question is, it's a larger question about performance. How do we?
Mhm.
There is this perception that Python is slow for things, and for some it is. Um, we like on one hand, we do believe that if you do things right, then Python can be a fast language. It doesn't have to suck.
Yeah.
But we also rely on, for example, for heavy numerical calculations, we rely on NumPy a lot, which can only be used outside Rhino. So there's always this balance of when can we use this. Um, for some of these things in which there is a fast alternative and a slow but available alternative, we sometimes keep both and then select based on context. Um, there's also this uh, uh, if in the steps in which we get something done is anyway following this premise of first make it work, then make
Mhm.
it right, and then make it fast. So uh, performance optimization comes last, but we do keep in mind what are the limits of Python in certain things. Uh, and specifically about the GPU stuff, Some I personally don't do anything with GPU stuff,
Hmm.
so I maybe not the best person to answer. Uh, I think some things are written for, um, especially for the visualizers that are the standalone visualizers, are written for like using shaders and whatnot. But general mesh processing, for instance, is not. It's usually just Python or NumPy, or what I mentioned before. We we rely on the native implementation of the context. So if it's a heavy operation, booleans is a good example.
Hmm.
Implementing booleans in Python would be insane. So we just use the best alternative available. So Rhino's SDK if you're in Rhino, Blender if you're not, Seagull if you have it installed.
Got it.
And then yeah, back to this picture. Then what happens is that the different teams will develop like domain specific extensions. Right? So I work in the architecture and digital fabrication chair, and we developed two of these extensions, the robotic fabrication one and the robot control extension. Um, then there is, for instance, a slicer also partially done by us and like half by us and DVT, Digital Building Technologies, volumetric modeling, and so on and so forth. Then BRG develops a bunch of the ones here and here, especially the FEA. And we are grouping these extensions into, and this is an ongoing thing. It's not done, but for conceptual reasons, we're grouping these extensions into, we call them AEC toolboxes. It's a
Hmm.
bunch of extensions that have a name that you can relate a bit easier than Fab, for instance. So digital fabrication. Okay, all these tools are here for you. Um, and we're going towards. This is still not ready, but we're going towards a. One of the things that we work heavily at the beginning and we keep working on is making the installation process easier.
Hmm.
Um, it's still right now it's still geared towards developers. Let's say you need to install Conda first, and then you install the package. Um, but we already have an alpha version of a graphical installer that will take care of all these things. So you can click a few buttons and then have Compas installed. And once we have that more functional, more readily available, then these toolboxes will take more of a real shape, and then you will be able to literally checkbox these things and get them installed. Um, yeah. Uh, okay, I can go into a lot of details, but I don't know if you want me to talk about these things.
Yeah. Uh, I really like how you showed like the example in the code base of like how the extension is talking to the core. So if we can like go through like one of the life cycle, let's say a geometry operation or like a particular extension functionality, that how things are being communicated, like API calls, that would be quite interesting.
Okay. Let me see. So maybe I can go here. So this is the. Okay, I was talking. Yeah, okay. I'll take the Boolean union that I was talking about before. Uh, and maybe to see this thing in action, let's see if I can actually show it meaningfully. Um, if I try to import this, is the size of the font okay, or should I make
Yeah,
it
it's
bigger?
okay. Yeah.
Okay, let me see if I, I want to show that this one is actually coming from a different. Maybe I can do this from Compas, right now, geometry, booleans, import this. Okay, no, bad example. But what I intend to show here is that open compass. That if I use Python and I import this very same line function, I also have a Boolean union mesh function here, which is not the same than the one I have here. But all of that is transparent to me as a user.
Okay.
Maybe I can show that with an example. Um, I have an example here.
Hmm.
Yeah. Let me change my environment. 1 second. Okay, good. Okay, let me explain now what I did. So I have this script, right? It's a rather simple script. I import mesh, box, and frame, and then I import this Boolean union, and I create two meshes out of these shapes, right? So two boxes, right?
Hmm.
And then I will union them, and after the union, I create a new mesh from the result and print the summary. If I do it here, that um, I'm running outside Rhino,
Hmm.
I get this result. There's a mesh that has 24 vertices and 66 edges. If I run the exact same code in Rhino, the mesh is different because the implementation for that operation came from a different.
Uh-huh.
This is the Rhino SDK implementation, which will do something very similar but not identical. It's just a different implementation of of the Boolean operation.
So, like, what's the single source of truth? Like, for example, like,
In which sense do you
so
mean?
if here's like one approach says 24 vertices, another approach says 34. So,
Well, both are correct. It's non-identical implementations of a Boolean operation. Um, they create visually identical results, um, with internals that are a bit different,
I
yeah,
I see.
but
And
compatible, right? So if I save this mesh from this side and I open it from this side, or vice versa, this is all a Compas mesh, so I can go back and forth without problems.
and if I compare two mesh, like, will both of this mesh will be same, or it will, like, I think it's because it's different vertices, it will say it's not same, right?
It will say it's not the same. Yeah.
Okay, yeah, I see. And uh, one thing, because this is Python based, I was like imagining, like, what if we implement it in Google Colab on a Jupyter notebook, and can we have like a cloud based implementation? And if I can create like a API endpoint in the Colab, I can just make API calls from Rhino or Grasshopper directly.
Yeah. Um, yeah, you can do that. I don't use it much in Colab, but I have used it, uh, to to the extent like, I even used Compass Fab in Colab, which requires ROS to be installed, which is a pretty large tool. Uh, um, but I remember we did an experiment at one point and it worked. It just takes forever to do all the pre-processing to get everything installed, uh, but it worked. But maybe more interesting. I mean, creating APIs is definitely possible, but we have this way. I don't know if you're familiar with this RPC stuff that we have in Compass. I guess you are, right? You mentioned it
Yeah,
sideways.
uh, but I think it's a interesting thing to cover in the session because it's quite cool.
Yeah. So we have this remote procedure called implementation, which is basically there to work around the limitations of Iron Python, but it also serves as a way of creating APIs. Um, uh, Usually, this is done like transparently for you. You say you are in. I can show it first from Reiner, but then I'll show a different way of doing this. Let's say I want to use NumPy from here, which obviously this doesn't work, right? Um, but what I can do is I can start with proxy stuff from Compass, and I can say, give me a proxy to NumPy, and then you have here you have access to the um, I'm not going to say to everything that NumPy has, because this effectively creates an API on the spot, and it has to be able to serialize back and forth the content. So not everything can be serialized, but a lot of things can. So what can I do here? Well, let me be boring and just say I'm gonna take this example linear from SciPy. And I can call linear solve for AB. Okay, I don't have an AB here.
Maybe on numerical data. There is. Uh, no, no, no.
Great. We don't have a great example for this. These things happen all the time. Um,
But
let, let me go back to the NumPy example then. Let me see NumPy API. Try to pick a
maybe
function
just
that's
like a
simple.
identity matrix or some basic test. Yeah.
Yeah, for example. Let's see if this works. I'm zero it. Uh, so we created an array, an NumPy array, and got it back. And here, and like big quotes, because we got back something that looks like an NumPy array. Of course, it cannot be represented as a real NumPy array on this side of the of the pond, let's say.
Mhm.
Um, but it looks and behaves like one, so we can do certain things and translate certain calls. This example is not really meaningful, but it means we can call stuff on the other side, outside uh, outside Rhino, but from within
Mhm.
Rhino. So uh, I'm gonna stop this. Remember. Um, and now I'm gonna do it explicitly. So um, if you want to start this RPC server, you can also explicitly call this Compas RPC start, and then you have you see that this is a server that it's running. When you do this proxy thing, it will implicitly do it for you, and it runs the server somewhere, and you don't see it. But this is what happens underneath the hood, and it also shows things like now it's listening and auto reloading modules. So if you are developing um, and what you're proxying is a module that you're working with, that you're actively developing, um, those things will be watched. The folders in which these things are going to be watched. And if you change them, it will automatically reload. And so the next time you call the API, it's fresh again. Um,
So basically, like we can access all the Python libraries which are in my virtual environment using this proxy server.
yeah, yeah, exactly.
Yeah. So I
And
think like this is pretty cool. So let's say if I like in Rhino, uh, and I am using OpenCV independently from Visual Code Studio Code, I can send the data of image by serializing it to the server. And can I also recreate and read the data from Rhino through that server and like decode it in image or bitmap format?
yeah, if the data types are somehow representable on both sides, yes. If they are not, then you need to pre and post process them so that they are. But yeah, you can send back and forth stuff without problems. One experiment, like, I'm gonna run this without ever having run this before, so I don't know if this will work. But living dangerously, uh, we saw that this. Let me see. We saw that this thing, the thing that we ran before, was creating the Boolean union, the Boolean union of two messages with Rhino SDK that created this thing with 34 vertices.
Mhm.
Uh, but I could actually try to use RPC and see if I can get the 20, what was it, 24, 26 vertices in
Mhm.
here, because I call it from outside. So instead of importing here, I'm gonna say, um, I'm gonna proxy compass geometry, and then I'm gonna call compass geometry dot move this one down. I don't know if the data types are serializable, but let's give it a try.
Fingers crossed.
Yeah, there you go.
Whoa, this is cool.
So now we have the same identical mesh Boolean operation done here.
So I'm guessing it's at a compromise of some speed where like in Studio Code we are directly calling the function. Here we are first making a connection. Okay, send this serialized data, do the compute, then unserialize it and read it. So there's some
Yeah,
time, but
yeah,
okay.
exactly. So the function needs to be worth the effort, basically. And underneath the hood, this is an HTTP request, which means the whole input will be serialized down to JSON and then deserialized on the other side, process, serialize, deserialize. So there's significant overhead. But if you have a like mildly complex operation, you bunch it into in, so you will never call the proxy inside a loop, for instance. That would be very inefficient. But if you wrap these things into a function and then do all of the processing in one call, then that works very well for plenty of things.
Yeah, and one question I have is like, so like HTTP is one way to implement it. One could also create WebSocket, and for API calls, there's like REST API, GraphQL API. Like, how do you make those decisions and architect that?
Um, the the decision for RPC to use HTTP is a bit based on what Python comes with as a default transport mechanism for this. Um, WebSockets, our implementation of WebSockets came later, so after we had RPC already implemented. Um, we didn't consider using it in that stage, but there is a separate extension that the VRG group uses. I think it's called Compas Cloud that does use WebSockets for that connection. They keep a more alive context on the
Mhm.
other side, and then they operate on sessions, basically on long running sessions. Yeah, GraphQL, we just didn't didn't have the need didn't have the need for that for now.
Mhm.
It's being a framework is not exactly um, you can create GraphQL APIs using Compass. I would say we don't have a GraphQL API ourselves for our own stuff because you're mostly going to be using this in process, not as a as a service, but you
Yeah.
can build on top. Yeah, I think extensions are more likely to use these technologies than the core.
Mhm. And and this might not be like fully like like relevant, but I'm curious to know, like, if I want to integrate Compass into the database and I'm doing like, let's say, machine learning data set creation, like what is the way you would approach this, like saving all the files, computation, and connecting to the database? What's the best way to architect that?
We do that to like in some projects in so it really depends on the project, right? At some level, what we do or what we can do is suggest to our researchers what we think are best practices for certain things, but this is already like perhaps beyond um, the core competence of the core framework, let's say.
Hmm.
Uh, but we have, for instance, we have in place all the mechanisms for data serialization, and these are important. So whatever storage infrastructure that you want to use, uh, any object in Compas can be serialized to JSON. That means that you can put it anywhere, be it transport or storage. You can put it anywhere. Um, the simpler implementations of storage are based on files, just directly, write it down to a JSON file on disk, and that's it. And considering the context and the workflows of research, and this works fine because very often this is like a experimentation happens on a single user phase for quite a while until they integrate with other people. Uh, but very rarely they will share a database of things, at least in our context. But for larger projects or projects that are more data oriented, we have different strategies. For I particularly like using time series databases for
Hmm.
things. So we use InfluxDB for example, which is again is since everything can be turned into JSON, it's almost trivial to put it into these databases. You just send
Hmm.
these objects and they go in. um, our communication via ROS, for instance, on the robot stuff, also somehow passes through a JSON bridge. So everything is more or less flowing in the same formats. So there's always a bit of a data wrangling, let's say,
Hmm.
adjusting the data schemes, but it's not rocket science. It's just fixing the data to the format that you need on the other side.
I see. Yeah, and Gonzalo, so we saw like one workflow from code to extension. Can you like give us some overview about like a wrapper, like how it's being implemented in this code base?
Mhm. This wrappers, you mean?
Yep. Yeah.
This one? I actually showed already. uh, what you saw happening here. So when I called this
Hmm.
boolean, I was actually calling. I don't know if you noticed, but the first time I called boolean from VS Code, I got a message saying I didn't have the plugin installed.
Hmm.
Maybe I can stop this and I can show it. This is my base environment for development. I don't have Compass Seagull here. So when I try to run the Boolean operation, there is no plugin, and it just complains. Um, what happened in the second time I ran this is that I switched to another environment in which I do have Compass Seagull installed, and when I run the same code, it called the implementation in Compass Seagull, which I think you can see if you just import Compass Seagull here. Yeah.
Yeah.
So we actually call this side and this side uh, in these two examples that I was showing, and you know the focus is really on you as a user should not care. You don't care
Mhm.
where it came from. It came from one of the implementations.
Yeah. Ac- Actually, my question was about like how is the library compass.seagull like composed uh like in the language, like in the main GitHub file, like how is that?
Uh, so okay, maybe this is a good intro for a different topic. A lot of extensions are built based on templates. If you go to our uh, organization, there are this template extension and template example, but the extension is the one we use very often. It's a cookie cutter template to create a Compass extension. And there's another one I'll show later how to create a Grasshopper component. But this one follows the structure of the Compass extension. We try to be consistent in how we structure all this all these different repositories. So all the code is in source, and yeah, everything is like a PyBind 11 binding. So these are the booleans that I was using, and so if you remember what I was
Mhm.
showing a bit before on the Rhino implementation and on the Blender implementation, you see the same pattern repeated, right? This time for Seagull, but there's a plugin of the Boolean union mesh that uses this function over here, which does this. So here we convert everything to NumPy arrays, and then we call union, which is union is from zero. So C code.
Mhm.
Yeah.
Y- Yeah. So yeah, like the confusion or like the things I wanted to know was like how is sometimes like you create Python to C sharp or .NET, like how is it communicating between different languages like wrapper or bindings, like is it you from like a binary data or like a bytes data and then call from one language to another language and have that bridge? How does the bridge work?
The bridge to C++ is usually based on PyBind. So it's a PyBind 11. So this thing, I guess you know it. Um, it's in process, right? So it's not there's no almost no overhead to this. Uh, this I think this is the only language that we can have this non-overhead bridge to. Well, for C sharp, actually, we can. I can show you perhaps a. Um, so this is a base library of Compass Fab. Actually, we use it when you use Compass Fab, um, and that's what I mentioned before. So bridging to doing the WebSocket implementation. Uh, if you are in Iron Python, it bridges also to C sharp, but there's no. It's again in process. The only thing we do is we import from the .NET libraries, and we use them and rely on the bridging that Iron Python does on its own. So the hosting, the dynamic hosting thing.
I see. This is super insightful. And let's say if I want to like have a front end app and communicate to the core function in Python, how would I approach that JavaScript to this?
If you want to have a HTML JavaScript application talking to
Hmm.
Compas,
Hmm.
um, I would you could use the RPC server as a backend. So the RPC server is an HTTP server, so you can call it from a web app, and we would be you can create your web application in whatever way you want, and you'll be able to call the RPC server. Um, in fact, it's even possible to run Compass and RPC as a service, let's say, in a Docker container. I think we tried
Yep.
that once for just for the kicks. um, and that's it. I would probably not do it if the application is like mediumly complex. I would not rely on RPC to be the server, like the entry point server. I would probably create a dedicated HTTP API based on some of this. I don't know, fast API or one of these frameworks.
I see. Yeah. Okay. So like since this is like server based, like literally any language can talk and read data and query data.
Yeah, there are some internally. We do have some like tighter coupled implementations for this. I think one of the guys in our team uses Meshcat. Okay, Meshcat for Python, which is this like it's a WebGL 3D viewer where you can not know that you're actually using JavaScript, but you are sort of, and you create this viewport that talks to the server directly, and then you have somewhat as like a very transparent communication. Communication here relies on something completely different. It's using um, zero and Q for connection, but
Yeah.
it's for a very specific use case, very different one. If
Hmm.
you wanna, and I would in general, unless the project requires, I would go for a much more decoupled architecture in which you have your web app, and it's a web app in whatever technology you want, and it's completely decoupled from whatever HTTP server that you want to use as an API.
Hmm. Makes a lot of sense. And I just realized if I were to make a web app instead, maybe I can use Streamlight and use like a Python based front end as well, rather than JavaScript based.
Yeah, you can also do that. Yeah.
Yeah.
I think it's important to keep them separated because it's very easy to be tempted to create a project, a single project that has everything end to end, but it
Hmm.
becomes super hard to manage. It becomes very messy very quickly.
It's amazing. I know it's like already crossed 1 hour, so are there any other topics which you wanted to cover?
Um, yeah, I think this is something that I
Hmm.
think it's important. Like one of the things that we've been pushing lately, well, not lately, it's been a while already, but as a mindset, let's say, it's been clearer lately that we want to have a clear process on how do we upstream research outputs, right? Upstream comes from this river analogy, waterborne elements flowing back. Um, but it's basically the process of contributing back to open source. Right? Things that happen in private research repositories, how do they end up uh, being pushed back into the open source repositories? Which, if we go back to the previous slide, a little bit tweaked, the whole the whole picture, when we are, at least for us at ETH, is that researchers will create their own research packages, right? Private ones, project specific, and they'll work on them for the duration of their research. Um, and well, obviously it's hard to work to create generalizations while you are also
Mhm.
doing like bleeding edge research. So usually first, the implementation comes to life at these levels, uh, and then we try to identify which components are candidates for upstreaming, and those can be upstreamed on a first layer of like degree, can be upstreamed to their own extensions. Right? So there's a project for I don't know, acoustics, and then we would create
Mhm.
a specific package for that. But it could also be that on a more granular level, there are certain plugins that can be created, extracted, so they don't have to be their own like full extension, but they can be a little plugin that plugs into core or one of the extension points in the extensions. Or they could be changes, modifications that go directly into core. That also happens. It happened a lot in the early stages, when we didn't have a complete implementation of the geometry kernel. So at some point, people were contributing a lot of the basics
Mhm.
to the geometry kernel, um, but now a bit less and less. So there are these kind of three um, types of contributions that we see as upstreamable as extension packages. So adding new domain knowledge to the ecosystem, uh, adding plugins, or modifying the core or one of the core packages of Compas. And here I want to talk about one little tool. Let's see. Well, okay. Maybe this is also something to point to. We put quite a bit of effort into having a consistent guidelines for development, so
Mhm.
that if people want to contribute, I can directly open it and create it. So the developer guidelines are here. We try to be consistent um, into how we expect code to be submitted. What are our style guides, what's the naming conventions that we use, all these things. We try to be very um, yeah, very consistent about it.
Mhm.
We also, like, since we are humans and we make mistakes, we we have them automated. So every time someone sends a pull request, there's a
GitHub
group
action.
number. Yeah, so we have a bunch of things that happen in the background. We first build against every platform that we support, Linux, Mac, and Windows, in the different Python versions. We build on Iron Python for Windows also. Uh, but then we run, and here you don't see quite well, but we run a lot of linting and style checking. Sorry, not here. So we lint. Maybe I can show this because this has been turned into its own. GitHub action that you can reuse in other projects. Um, no, sorry, where did I end up? Not here. So we create like isolated environments and test that the pip install works. We lint the whole code and then run all the unit tests uh,
Yeah.
that we know that.
I had a question, Gonzalo, about running those unit tests. Like, how do you identify the failure mode in case like something stops in between? Like, are there any like things you log to understand at what was the failure point?
Yeah, this is done by GitHub Actions basically. Okay, here we have a failing check. Iron Python fail. So here you can go in and you can see. Well, this is a very boring one, but you have the entire. Well, maybe this is an old error. They don't have the log anymore. Let me try to find a more recent fail. Um, well, actually, I can just show you anyone. It doesn't have to be failing, but you'll see that the logging is very complete. Um, yeah, here you see the
Oh,
whole
I see.
installation process and the whole. This is the test cases running. So the unit test running, and if there were any errors, you would see them here.
Got it.
Yeah.
And
Mhm.
and also like many times like while using TensorFlow, I see like the same model. If we change the latest version to TensorFlow, it gives error. So what are some things you do like in terms of maintenance that when let's say a per, you num a person uses NumPy's latest version and there's a conflict or the function is not available in older version with Compass, like
Version the dependency management is it takes up quite a bit amount of resources on our end. We are very usually very picky in how we set our requirements. So, for example, we have this thing with matplotlib that matplotlib will be installed on a very particular version. We know these ones work, these ones don't, depending on your context. If you're in Windows, these ones work, and if you're not, um, same thing happens with image.io. Cython, we had this problem until recently, but just a few days ago,
Mhm.
we managed to get rid of this issue. But yeah, we do need to keep an eye on this all the time. Different versions break all the time. There's another level of automatic checking that happens when we build this into Conda Forge. Uh, because every time we release a new version, there's a lot of automation. Otherwise, it would be impossible. We're not a team of 35 million people. We're just
Yeah,
4 or 5 core developers plus additional ones. But it's if it's not automated, it would be impossible to maintain. So every time there's a new release created and the release process is also automated, we just say invoke release and the whole thing is created. Once a release is created and pushed to as a tag to Git, uh, GitHub will build the whole thing and it will push the release to pip. And the release from pip will automatically trigger the rebuild on Conda. which runs another set of checks on the Conda ecosystem, let's say, on Conda Forge system. So this one builds again for all the possible architectures available. Uh, so, for instance, now we are where is it? Yeah, we are we are at this stage. We need to add support for the new silicon of Apple, but well, not new anymore. But if you install Compas on an M1 uh, computer,
Mhm.
um, it will still go through the Rosetta emulation today, and that's only because we currently we have a dependency to a project that has not yet migrated to the M1 architecture, uh, but we just removed it. So we have cleared the way to rebuild it. So next release of Compass will be supported natively in M1s, for instance. Um, yeah.
This is
And
incredible. I love like the automated testing, the templates you have created, the recipe. And, like, this is super super insightful.
one thing I want to show, like in the context of templates, is this thing. We started creating Grasshopper components a while ago for some of these things. One of the things that we're pushing towards is raising the level of abstraction. At the very beginning of Compass, Compass was completely aimed at architects who are proficient coders, let's say.
Mhm.
And we've been lowering that barrier of entry, let's say, to make it more accessible. To now, Compass Fab in particular, we started there, has a lot of Grasshopper components, so it can be used without coding. Um, and we're like constantly inching towards, this has to be also usable for people who are not coders, and interchangeably, right? We're never going to go in the direction of creating closed components or things like that. So the components that we are creating, uh, they have to be just wrapped code, but they need to be wrapped nicely so that someone who doesn't want to code can not code. And those who do want to code, they can still interact with it. They can either view the source of a component and change it, because I think I think view source, like literally the right click view source from
Mhm.
the internet, is what made the internet successful. It's the way that a whole generation of developers was raised learning on their own. So if you can view the source of code of whatever you're using, you can learn. So one thing we did a while ago was creating this tool that stupidly called GH componentizer, which it takes. I don't know if you probably, yeah, I'm sure you
I haven't
created
used it.
those. Ah,
Yeah,
okay.
like I have created GH Python components,
Yeah.
but like not the this
Okay. Yeah. No, but
component.
when you create Grasshopper components, you either have to create them in C sharp, right, which takes a whole different workflow, developer workflow, or you can use this GH user stuff, but it takes like a gazillion of clicking to get one component out, and it's really non-automated, and also not very friendly in terms of source control, because you end up with a file that it's opaque, that it's a binary, not very not very fitting to our stuff. So what we added um, is this guy called componentizer. Where do I have it? Actually, I'm just going to show you the components first. I'm going to show you one of the Compass 5 components. So we wanted to create components without um, without having to open Grasshopper in a way.
Mhm.
Um, so we came up with this very simple structure in which one component can be created with three files. One is an icon, of course.
Mhm.
One is metadata, where you add all the text and all the details, inputs and outputs. And the other one is a Python file with the code that goes in it. That's all you need. And then you run this component type cycle, which you can run. We run in automation in CI, but you can also run it from the command line. I never remember the command. And it will take all these things and output GH user stuff.
Whoa, that's
And
amazing.
then, and then we just sort of compile these things in automatically when we create a release, and these things don't have to be compiled by a human, and they're always fresh. Uh, so that's a way in which we want to help or make it easier to lower the barrier of adoption. And so you can also create your own components. Like, you don't have to be creating components inside inside Compas. You can use this from. This is just a GitHub action, so you can use it on your own project for your own stuff.
So I can easily make plugin now
Yeah,
in
exactly.
Castle.
Yeah,
That's cool.
and
And
it like as a side effect of this. Sorry, last
mhm.
one, and then I'll stop and I stop talking. uh,
No, I'm
but
learning a lot, so you keep going.
the side effect of using this mechanism is that these are the plugins that we just generated, by the way. Um, they're not opaque. You can double click them and see the code and change it. This is view source. You can always view the source of what we're doing, what you're using.
I see. Like I'll keep this question for next time, but I really I'm curious. I'll study this GitHub repo, like, but how you engineered this from Compass to like .gh user? I think this is cool, super cool. Okay, Gonzalo. So on the website I saw Compass 1.0. So is like Compass 2.0 coming, or like what's the vision? What's coming next?
Uh, I, I I guess it's a very bad idea to announce deadlines publicly, but yes, Compass 2 is coming. I'm not going to promise dates, but relatively soon, let's say. We are inching towards the last versions of the 1.0 series. So we're gonna release like an LTS version of 1.0, a long-term support version, and then we're gonna halt development on 1.x branch and switch to 2.0. We do follow more like a rolling release sort of mechanism. So from the last version of 1x to the first version of 2.0, there won't be perhaps a gigantic change immediately, but there will be breaking changes. So there will be bigger cleanups and some reorganizations that we have been. So for the entire 1x series, we kept backwards compatibility in the API so that you can keep updating without breaking. Um, but all of that is marked as deprecated, and it will go away in version 2.
Mhm.
So there will be a big cleanup of a bunch of things. Um, and there's a lot of new features that I cannot really talk about without
Yeah, yeah,
promising
no
too
problem.
much. But there's a bunch of things in in different domains. So we're working on stuff from different from XR to whatnot, and some of these things will go, will end up being upstreamed into the core soon. Some others will live in separate extensions for a while before they make their way into core. But yeah,
Oh man, when you said XR, like my excitement got doubled. I am looking forward to the second release. So,
cool.
Gonzalo, I do a rapid fire round at the end of each session. So
Mhm.
I'll ask two, three, like I'll ask couple of questions, and you just have like 10 seconds to respond in very short answer.
All right.
Okay, let's do this. So, which city is in your travel bucket list?
City in my travel bucket list. I want to go to, well, not a city, a country. I want to go to Sri Lanka for surf camp this summer.
Oh, that's exciting. Uh, any business or technical book which made a big impact in your life?
uh, Technical book, or author, I would say Martin Fowler. Uh, Everything that he wrote, amazing. The guy is the peak of semantic clarity. I would say his every word has exact meaning in his universe. Yeah.
I'll definitely check that out. Your role model?
My role model. Oh, that's very hard. Um, I don't know if I can answer this in 10 seconds. The pressure, oh my God. I don't know. There's a lot of people I look up. Um, um, I I will have to say I actually like a bit of a weird answer, but I admire a lot of people that are outside our industry, people that are in creatives like writers. Some of my favorite people in the world are I don't know, Jose Saramago from Portugal, a writer. Yeah,
I see.
these people.
Uh, your favorite movie?
My favorite movie, I have lots of favorite movies, but my most recent favorite movie, The French Dispatch from Wes Anderson. Very good. It's still in the cinemas, probably.
Hmm.
Highly
And
recommend
any open source library except Compass, like which you really like?
it. An easy answer to that is requests from Python because it's beautiful code. It's done very nicely, very cleanly. Yeah.
Mhm. And uh, what is your piece of advice for people who are interested to do open source development in AEC?
Not just in AC, in general. One of the biggest struggles to start contributing is actually uh, um, feeling that you're entitled to do it. Feeling that you are allowed to, because at the beginning you think, no, I cannot. This is for other people, not me. But that's a lie. Any contribution helps. Everyone helps. Every little bit helps. So just start with something small that you feel comfortable with. Can be even documentation if you're a bit uh, scared about contributing code at the beginning, but just get started and you very quickly notice that there's no barrier there. You can just jump, and it will actually help your own personal and technical development. Like you will grow as a developer by contributing. You will be talking to other people that know uh, more than you. I mean, the beautiful thing about open source is that you'll always find people that know more than you, and it's always good to find people that know more than you, because otherwise you're not learning, right?
Yeah. And is there anything you wish you would have done differently while implementing Compass?
Uh, we always make mistakes, right? We're humans, but I would say no, because it's not that that I regret that we did something in one way and it's a permanent error that cannot be removed. We are always refactoring the code. So yeah, I mean, some things were done in a way, but then we change our mind and we change the implementation. So, and we will keep doing that. So
Awesome. Yeah. Thanks a lot, Gonzalo. Like it was super interesting interview, and like really proud of all the open source work and better improved workflows you are developing. And like I'm just gonna make a separate document of like principles and guidelines for open source AC document, and like compile all the things you are doing.
cool, cool. Thanks. Yeah, thanks a lot for inviting and hosting. And yeah, and it's been a pleasure.
Mhm. Awesome. Have a nice rest of your day, Gonzalo. Bye.
You too. Bye bye.